Ever noticed how a perfectly clean room inevitably descends into chaos? Or how an ice sculpture, beautiful and intricate, slowly melts into a puddle? That, in a nutshell, is entropy at work. Entropy. It's a big word, but it describes a fundamental force that shapes the entire universe. Think of it as the universe's unstoppable slide into disorder. Everything, from your messy desk to distant galaxies, is subject to its relentless pull. This isn't just about things getting messy, though. Entropy is deeply connected to energy, information, and even the arrow of time itself. It governs everything from the smallest chemical reactions to the largest cosmic events. In this video, we're going to unravel the mysteries of entropy. We'll explore what it really is, why it happens, and how, against all odds, life and intelligence manage to fight back against this universal tendency towards chaos. Get ready to have your understanding of the universe, and your own existence, turned upside down. The story of entropy begins, rather surprisingly, with steam engines. Sadi Carnot, a French military engineer, was fascinated by the efficiency, or rather, the inefficiency, of these mechanical marvels. In 1824, he published Reflections on the Motive Power of Fire, a seminal work exploring the limits of how much work you can extract from heat. While he didn't use the term entropy, he laid the groundwork by identifying the fundamental asymmetry. Heat flows spontaneously from hot to cold, never the other way around. This insight was crucial. Fast forward to the mid-19th century, and enter Rudolf Clausius. This German physicist took Carnot's ideas and formalized them, coining the term entropy in 1865. He described it as the measure of the energy dispersal in a system. Importantly, Clausius declared that the entropy of the universe always increases. This was a bombshell, establishing the second law of thermodynamics in its classic form. But the story doesn't end there. Ludwig Boltzmann, an Austrian physicist, provided a revolutionary statistical interpretation of entropy in the late 19th century. He connected entropy to the number of possible arrangements of atoms or molecules within a system. Think of it like this: a neat stack of papers has fewer possible arrangements than a scattered pile. Boltzmann argued that systems naturally tend toward the more probable, disordered states, a far more intuitive understanding of why things fall apart. His famous equation, S equals K log W, forever linked entropy to probability, a concept so profound it's engraved on his tombstone. These early pioneers, grappling with heat, steam, and the very nature of order, gifted us with the concept of entropy, a concept that continues to shape our understanding of the universe and our place within it. Okay, so entropy isn't just a mind-bending concept for physicists. It's got real-world applications that are shaping our lives right now. Think about information theory. Claude Shannon, the father of information theory, brilliantly linked entropy to the amount of uncertainty in a message. High entropy means more randomness, making it harder to compress data efficiently. This principle is at the heart of data compression algorithms used every single day to stream videos, download music, and store all sorts of files. Without understanding entropy, we wouldn't have nearly the digital storage or bandwidth we rely on. Then there's thermodynamics. Engineers use the principles of entropy to design more efficient engines and power plants. By understanding how energy dissipates as heat, which, remember, is an increase in entropy, they can minimize waste and maximize power output. This leads to better fuel economy in your car, more efficient electricity generation, and ultimately, a smaller carbon footprint. Even in areas like machine learning, entropy plays a crucial role. Algorithms use entropy to measure the impurity or randomness in data sets. This helps them make better decisions, classify information more accurately, and build more effective models, from spam filters to medical diagnoses. Entropy helps power the artificial intelligence that's becoming increasingly integrated into our lives. And let's not forget cryptography. High entropy is essential for creating strong, unpredictable encryption keys. The more random the key, the harder it is for someone to crack it. So, the next time you're shopping online or sending a secure email, you can thank entropy for helping to keep your information safe. Ultimately, understanding and fighting against entropy is what drives much of our technological progress. We're constantly developing new ways to organize, order, and extract useful work from a universe that's always trying to fall apart. It's a constant battle, but it's one that leads to innovation, efficiency, and, hopefully, a more sustainable future. So, let's recap. We've seen how entropy is essentially the universe's way of saying, things fall apart, from messy rooms to decaying stars. The second law of thermodynamics is always at play, driving everything towards greater disorder. But we also learned that life, consciousness, and even technology are incredible pockets of resistance, cleverly using energy to create order in a chaotic universe. At least locally, we're fighting a losing battle in the long run. Perhaps, but it's a magnificent one. Looking to the future, understanding entropy might be key to breakthroughs in everything from energy efficiency to creating artificial intelligence that truly understands the universe's limitations. Perhaps one day, we'll even find new ways to bend the rules, or at least play the game more effectively. The quest to understand and manage entropy is a never-ending one, driving innovation and pushing the boundaries of our knowledge. If you found this exploration of entropy mind-blowing, give this video a like, and don't forget to subscribe to the channel for more deep dives into the fascinating corners of science. There's always something new to discover.